All right, everybody, welcome back to the channel and welcome to today's video. And in today's video, I have a very special guest from Helio Additive to show us all about Helio Additive, and that is the CEO, David. David, do you want to introduce yourself?
Yeah, Len, really great to be here. Thank you very much. And hi, everybody watching. My name's David Hartman. I'm CEO and founder of Helio Additive. Well, what can I say about myself? I've been in 3D printing for about a decade. And it's really, personally and also in business, it's one of my massive passions. And I really founded Helio Additive to solve some of the fundamental problems that are holding desktop 3D printing, but also generally just, plastic extrusion 3D printing back.
Awesome, awesome. So I'm really excited to have you on the channel today. I really appreciate reaching out and setting this up. So let's go ahead and get started and learn a little bit more about Helio Additive. I've had your product on my channel a couple of times. But tell us, how did you get started with Helio Additive, and what was kind of your aha moment to really kind of dive in and do something here? I think you kind of touched on that in the intro, but what really got you excited and motivated to create Helio Additive?
I've been watching desktop 3D printing for a long time. I used to build my own printers for my own hobby, like Delta printers and things like that. But then also for work, when I'm visiting factories, you'd see like this really old injection molding line, right?
Hmm.
And then next to it, you'd have some kind of state-of-the-art desktop 3D printer. And so you'd have engineers in the factory using, they're doing manufacturing, and then they're also bringing in their hobbies, mainly around desktop manufacturing. And so what I thought was interesting was that um, it's pretty clear what we want from desktop 3D printing. We want, reliability. We want to be able to click and get something out that makes sense. We want to use a wide variety of really exciting materials, because life is not just PLA, right? And it, uh, well, I think we want functional materials, right?
Hmm. Hmm.
Like my favorite material is polycarbonate. Why? Because it's just strong, high temperature, and whether you're doing that RC plane fuselage or a jig and fixture in manufacturing, it's a material that won't let you down, right? Um, and so for me, watching what was going on in desktop 3D printing and talking to people, and certainly my circle of people in 3D printing, was clear that kind of one of the key things holding 3D printing back is that that it's an enormously complex process that we don't really understand from a physics perspective. Um, do you mind if I rephrase that a little bit,
Sure,
or
sure, sure.
do you want me to go in more detail?
Yeah, go into more detail into that, and maybe the problem that you're trying to solve there. I think is really really interesting, and I think you may have an analogy as well.
Yeah, and I don't, to the viewers watching this, I don't want to bore you, but let me, when you're printing something and you've seen this, you're layering down millions potentially of hot droplets of plastic, and how these droplets are cooling really defines how well your part is going to print, how many defects you're going to have,
Hmm.
whether you're going to have warping, that kind of thing. And I think in manufacturing in general, that's pretty unique. The only other place where I kind of see a similar level of complexity is in composite manufacturing, where you have a continuous fiber or a tape of some kind, and you've got it inside a thermoplastic resin matrix. But apart from that, it's really unique in terms of complexity. And if we don't understand what's happening in the process, then it's all just guesswork, right? That's why we have those thousand settings in the slicer, because we're lucky, there's been 15, 20 years of people using 3D printing, doing guesswork and trial and error, and then recording some of these things and then saying, oh, well, now I'm going to create this setting because that solves a specific problem that I have. But it's not really based on an understanding of what is fundamentally going on in the process. It's more like we did some stuff, it didn't work out, then we go back and make some changes. Now it works out better. And so whatever change we made, we kind of say, okay, well, that solves that problem. But we don't really know why. So what we set out to do is, or what kind of the epiphany, the aha moment for me was, well, if we can understand from a physics perspective what is happening to the plastic as it cools during each one of those hundreds of thousands or millions of moments where plastic is being deposited in the printing process, then we can start to say, well, how did these bond together? And when I have a picture of all of those added together, then all of a sudden I have a picture of how well is that part going to come together in the real world as one overall part. And that was really kind of the aha moment is if we understand this in the detail and then we can add up that understanding, and if we have that from kind of a polymer physics perspective, then all of a sudden a whole lot of problems in 3D printing can be demystified and solved. And yeah, that's what we do.
That's awesome. That's really, really awesome. How has your mission changed or evolved since you've started and since you've got started in doing this from just looking at the physics and everything? How has it evolved into what it is today? Like, talk to us a little bit about that process.
I think so. I mean, you've seen this just as long as I have, Len, how desktop 3D printing has changed over the years,
Mm-hmm,
right?
mm-hmm.
When I started, we were based in China, so we know a lot of the people in Chinese 3D printing. So we'd already talked to people like the Bambu Lab team before they were public, or we know the Polymaker team really well. For me, the kind of main thing is watching, okay, hardware is going to make these leaps and jumps forward, and materials are going to make these leaps and jumps forward, and we're going to get, cool things like much faster printing speeds. And we're going to have to, and our mission then at Helio is even more important because the better your hardware is, the more sophisticated you need to be from a software perspective when you control it. Um, I try to do analogies because everybody here and you guys listening, you all know about 3D printing, right? But generally, people are not that clued up on what 3D printing is about. So what I tell people is I say, look, it's like you've got this really fast sports car, but you're driving it at night through the forest without headlights.
Yeah.
And so you're going to be, you're not going to be driving this thing very fast, right? Um, and so what we're doing is we're giving you the headlights, we're giving you the GPS, we're giving you the autopilot, so you can just, make this thing go reliably as quickly as it possibly can. And when we saw, to cut that long story short, when we saw this industry advancing and increased print speeds, better hardware, new high-speed materials, I think that was for us kind of oh wait, we're becoming even more relevant here. And this is not just a painkiller for people, but this is like oxygen. Because if you want to really push the boundaries of what's possible, you're going to need some kind of physics-based control software.
Very, very cool. Very interesting. So for a lot of my viewers, we're just kind of the average non-engineer, like I can make
Mm.
stick figure theater and fusion and maybe a little bit more advanced than that. But what would be the benefit of using your software with the Bambu printer lineup for the average user like me? Like, what are the main things that we would see as a benefit? As just the average user like myself. For manufacturing, I could see really fine tuning your part and then being able to produce it massively would be a great benefit. But for an average 3D print user like myself, like what's that big thing that we can take advantage of?
The first thing that I would say is I think we're kind of like a quality tick mark or an insurance policy, right? Um, when the and we can talk later about how it specifically works, but when the optimizer runs on a part that you've sliced, what you're getting is you're getting this insurance policy that you have a much higher chance that you're going to have a success rate. So for me, even as like I'm not I'm sure you guys are more sophisticated 3D printing users than me, but like when I'm printing with my 12-year-old son or whatever, and we're doing something, I'll run an optimization or he'll run an optimization because we just want that quality assurance. We just want kind of a, okay, there's this blanket kind of guarantee or seal or tick mark that things are going to work great. So I think that's the foundation. And then when you get on top of that, I think the the speed improvement. So in most cases, we can offer you somewhere between 10 and 40% speed improvement, the increased strength of the part. So in most cases, we can increase the bonding and the reduction in warping. Those are kind of the three that for the average user are really useful.
Yeah, so that really makes sense, especially from like my 3D print journey. That kind of lines directly up with it because I started on, a $200 Amazon special, and I had to tinker with that thing to get it to print anything that you could use, right? And I think the whole reason that I've jumped onto Bambu and have 3 Bambu printers now is because of the quality or whatever, and how easy it is to get that quality. And it's not tinker free, but definitely tinker less tinkering that you have to do to get like a quality print. So um and I think the reason why I have 3 Bambu printers is because I can rely on that quality all the time. But it does suffer in some areas. Like not every single print is good, and sometimes I suffer with some of the prints. So to even be able to optimize it and kind of get that peace of mind of, this really cool print that I'm making for a family member or for somebody is gonna, turn out great. I think lines up with kind of the journey that a lot of the people like on my live stream have had, the similar journey from a really cheap printer that was really hard to use to moving to something that was easier to use, and you could get more reliable prints out of it, to buying multiple of those and doing a whole lot of things, to now looking at taking that next step of how can I really ensure that these are going to be optimized to the fullest to get the best quality that I can. And then I saw in the new update that it's showing like time saved that you're doing by optimization and doing things like that. And then, I think functional prints is another area for like the average person, with like Maker World and stuff being opened up in that regard. It's easier to get like hooks and jigs and stuff that I can use in my wood shop. So to be able to optimize those for ABS or ASA or PC or anything like that, to make sure that they're going to be the best functional print, I think is a great thing for the average user to do as well. And that's some of what I've been using it for as well. The main thing is iterating through a flight controller stand for one of my RC planes. But I also did some optimization, like on some tool holders and stuff for ABS that went into my wood shop upstairs as well. Stuff that can drop on the floor and not shatter like PLA or something like that. So really cool, really cool.
And don't you feel, Len, when we're talking about this, that we're somehow in a transition moment for 3D printing? And there's just so many factors like what Bambu is doing and triggering innovation in hardware is one thing, but then also what you're talking about with the move from kind of aesthetic parts to functional parts, it just feels like the last 10 years of 3D printing journey, at least for me, is culminating in some kind of big change that we're living through maybe in the next over the next 36 months or so.
Yeah, yeah, definitely. And I think as 3D printing gets more and more faster, reliable, better quality, and all of those things, it'll be used more and more for everyday parts. So my big thing now is anything that is all plastic, I refuse to buy. And I either
Mhm.
make it in Fusion and make it, or I find a model on Maker World or Thingiverse or somewhere like that. Um and totally make it. And the example being is the last time we talked, this computer was in a different room, and I told you I had to bring it into my studio and do everything. So I brought in a hard line Ethernet cable. Actually, the people can see it, or you can't see it, but it's right here in the corner on the video here. And the little adapter that goes into the wall, like the wall plate or the little thing inside of the wall with the little
Yeah.
latches that holds onto the drywall. I 3D printed that. I used a screw, but I 3D printed that. It mounted it in the wall. The little thing that holds the keystone for the Ethernet connection, I 3D printed that and used that. And then the plate, those are called Decora plates, the ones with the squares or whatever. I 3D printed that. And I 3D printed almost all of that as fast as I could have drove to Home Depot and bought it and came back. So even like just the
And
drive time and back, I was able to print all of that on my H2D in relatively about the same amount of time for about 75 cents.
what material did you use?
I just used PLA for that because it's just holding little
Okay.
things in there, and it doesn't need to be super strong. But I mean, I could have used ASA or something. That's what I normally use on electrical boxes or things like that. But for something as simple as just an Ethernet cable to jump into this room, PLA, and I spit it out
Yeah,
75 cents, and it took 45 minutes, which is faster than I can drive to
it's
the store
amazing.
and back. So the more that we
Yeah.
can do things like that, I think what you're saying is correct. Like there will be a revolution of, it's not just the aesthetic prints. The aesthetic prints are what get people's eyeballs into 3D printing, but it's the functional prints as to why they buy the 3D print, the 3D printer, I feel. And that's why I got into 3D printing in the first place, was all over a functional print as well. And the easier that gets, and the better quality that stuff becomes, I think you're right. Like there'll be even a more revolution where it's not just people that, I'm not an engineer or anything, but I tinker a lot with a lot of different things. So I'm not scared to jump into some of these things. But it's almost this is as near plug and play as you can make it. I think right now. So the more easier it is for the non-person to where I can just click on something and click it in Maker World and it opens it up in the slicer and you hit slice and print. Like it's pretty easy. And the more people can do that just for the everyday things that they have, and have different materials in their AMS for the different types of things that they want to print on a daily basis, I think there'll be a large revolution in 3D printing, as well. And as fuel costs go up and everything like that, it's, you can fit more filament in a truck than you can finished goods in a truck. And the
Yeah.
company that I work for, that's kind of the philosophy. I won't get into too much of their philosophy around that, but you can transport filament a lot more effectively than you can a finished good. So if you have 3D printers everywhere and you're just shipping filament to places, then you can cut down on a lot of fuel and energy cost, and make it effective, especially for things like an outlet plate that you can print in like 30 minutes. The amount of gas to drive to the store and back, or even in an electric vehicle to recharge that vehicle coming back, there's costs and road wear and all of that stuff. So I think that
Yeah.
it's coming to where just the average person is going to have a 3D printer like they have a cell phone, like they have a desktop printer for paper, just like you have an internet connection and things. I think it's getting very close to people having 3D printers like in mass or en masse.
Yeah, I feel the same way, and that's why in this new version, and we're going to talk about new features, but we added in what we were getting a lot of requests for, which was the A series and the P series, because the people that we're talking about here are probably going to be using. They're probably not going to have the H2D, right? They're probably going to be using A series or P series at home to do these things. So we just added those in. Yeah.
Yeah, so talk a little bit more about that's a great segue into the new features that you released here this past week. I saw one of them was the, how much time is optimized by the print and everything, and then you said you added the A and the P series. Are there any other features that you added in this last update?
So one thing is what happens at the front end. The other thing is what happens in our physics engine, the cloud. So we've been, you'll notice that optimization is slightly faster now, which is,
Mhm.
I think, the faster we can make it, the more value we can add for users. It was already really fast, and now we've given it another speed boost. We added in the A series and the P series. And it just blows my mind how widely used the P series is. We don't have the new P2S yet. Is it what did they just release? The P2S, right?
P2S, yeah,
Um,
P2S.
yeah, we don't have that yet, but the P1P and so on, the older P series, we have them in there, and they're just getting, whether in a factory or in a home setting, the market is for that, the demand for that is just huge. And then the A1 and the A1 Mini. And then on the front end side, I don't know whether you can show us Bambu Studio briefly, Len,
Mm-hmm.
or shall I share my screen?
No, I have it. I have it up, and I'll
You have it.
I'll pull up.
Okay.
I have a model
If we-
pulled up here. All right, so we have a model loaded in here, and I have PC loaded. Sorry for the brief technical difficulty there. So let's go ahead and slice it, and then we'll bring up the optimization. And then the advanced
yeah.
settings is also
So
something that I saw. And then the optimize outer walls. So do you want to kind of walk us through what all of this stuff is here?
absolutely. So your buttons are a little bit, the simulation and optimization kind of tabs that you have at the top are a little bit deformed, right? But on a normal setup, these should just be looking normal. Simulation. So when I talk about simulation, simulation is like a map. We give it for free. What you can do is play some scenarios like, okay, what happens if I change the chamber temperature, and then it'll just simulate that G code that all those settings that you've selected, and then you can see, okay, is this going to print well or badly by the view that comes out the other end? And then you can go back and you can make some setting changes, like switch off the fan, or switch off the fan for just a couple of layers, and then go back and run another simulation and see whether you fixed it. So simulation for us, we're offering kind of this um, scenario playing tool for, oh, how well is this going to print? And what we're seeing, I think we've had 90,000 simulations run since we launched. That's really been awesome to see users engaging with that.
Yeah,
But
that's
we want
great.
to, yeah. But let's have a look at optimization today because that's where we've made our changes. So at the top, you see the quota. This is the number of optimizations. If you want to buy more optimizations, there's the buy now button at the bottom, which takes you to our storefront. Um, you and then below you have add-ons available. So I think we can maybe clear up a misunderstanding there. So you can buy a subscription to Helio, which gives you every month a certain number of optimizations. But then you could also, let's say, if you've just got a specific project that you're working on, you could also just buy add-on optimizations, and you would not have to have an active subscription for that. So what we wanted to do is give the community a choice. You could either subscribe and then you get like a certain cost benefit, but if you just want 10 optimizations because you're only going to run it a few times, you can also do that and not go for a subscription.
Yeah, and that's really great, and that's something that I would recommend to everybody is just to buy 10 or 15 of the optimizations just to try it out and to see if you like it. And if you're not going to use it every month or whatever, and it's just going to be every once in a while, that would be a great way to still have that as well. So it's great that you have a consumption model as well as a subscription model for people that are doing a whole lot of printing like myself. The subscription model makes a lot of sense, but I know for some people, just buying 10 or so optimizations at a time might be the better way to do it.
Yeah, yeah. Our we just want to help, and be and give people as much power as possible, right? For me, 3D printing is kind of like the Iron Man thing, giving power to individuals to do whatever they want to do, right? So my favorite superhero is by far Iron Man, and yeah, giving people choice like this means that they have the maximum power.
Awesome.
Um,
So tell us a
so
little
go
bit more about the rest of this here. The optimize outer walls, and then the advanced settings is something that I've seen that's new as well.
So outer walls is really you may be so what our simulation optimization engine is doing is it knows exactly for every little element that's being printed what the temperature, what the cooling window is that this element should be in to print perfectly. And so what it will do is it will adjust the speed of printing, because generally when you adjust the speed of printing, like if you print faster, your there's more heat trapped in each element that's being printed, so that things are going to cool down more slowly. So it'll speed it up or slow it down in order to try and hit that thermal window. So generally, you don't have any issues with outer surface quality, but maybe sometimes you are really, really focused on getting a particular surface quality. And so what we allow people to do is kind of say, okay, I don't want you to touch my outer surfaces. I just want you to touch infill. And that's where the optimized outer walls is. I usually just put it onto yes because I want to get the maximum speed boost that I can and the maximum kind of strength boost. But we give it to people as a choice so that they can have control over that.
Yeah, so
Um,
I'm thinking like I don't know if you support like the silk or the metals or whatever, but you on the outer wall you really want to run it very slow on the outer wall to get a specific shine or whatever. So that makes a lot of sense if you don't want it to
exactly.
do that outer wall optimization and you've already optimized or already got it exactly how you want it and you just want the inside. That's when you select no. But if you want it to optimize everything, then you go ahead and select yes here. Okay, that makes a lot of sense. Thank you.
Yes. Then the other advanced settings, quite honestly, I don't really touch the first four at all, which is the printing velocity, right? So the speed, the min max speed, and the min volumetric speed and max volumetric speed. Volumetric just means it's, the feed rate, right? The amount of material that's going through. The reason we have those in there is because some very advanced users may be better aware with their materials what limits they can push, and they want to make some changes there. For me, I think we already give the most optimized performance there, and so personally, I don't touch those. What I do touch sometimes is optimize specific layers. So I might say with a larger part or with a part that has one area that's particularly complex or has a different layer size, I'll say, okay, well, I only want to optimize these spaces, or maybe I've got, you know, 10 or 20 bottom layers that are quite that I'm fine with and I don't want to touch and I want to print more slowly. And then the upper layers I want optimized. So that's the kind of thing I can do with that layers to optimize setting. Um, yeah, personally, I think for most of the users, for most of you guys that are watching, I would just stick to the outer walls question, put that to yes, and just run start optimization. I wouldn't think about these things too much unless later on you're encountering some changes that you want to make.
So the 99% of the time, just mess with the outer walls, hit okay. That 1% of the time, when you need to really fine tune some stuff, go, you have the advanced settings to do that, but you don't
Yeah.
need to necessarily tinker with this every single print.
No, I definitely wouldn't do that. It's definitely that 1% of cases. I just leave that be most of the time. Um, and then yeah, and then you press start optimization, and maybe we can quickly run an optimization. If you can just open those tips, because I think that's super useful information that not many people are seeing. At the bottom where the progress bar is going, there's that daily tips thing. Yeah. So what we do here is we've worked with Bambu to put these tips in there because we wanted to give a little bit of education on what's going on, what are some of the things that you could do better. There's a link to our wiki. So the wiki has got a ton of information on it. We've tried to be really open about what's going on there. And I think there are 16 of these little tips at the moment. And that's kind of a mini journey for taking you through building a better mental model of what's happening. Yeah. Oh wow, that's the speed improve. That's the simulation and optimization improvement that we've just done, right?
Yeah, it was
That
taking
optimization was super fast.
yeah, I was taking a solid 4 minutes before, and that was, just a couple of minutes now.
Yeah.
And that's interesting.
Um,
I didn't know that you guys had put some tips and tricks into the little daily tips there. That's awesome. The one thing I
and-
wanted to ask while this was printing, this is another thing that came up on our last call, and I wanted to give you an opportunity to talk about this as well. This little mount is for a camera that I downloaded from Maker World, and I just sent it through your servers or whatever to print, right? So this free model that I printed, are you taking my free information that I got for free and using that to train a model or do anything like that? I think you had said that you had saw in some comments a lot of questions around that. So I wanted to, as we're doing this is a free model that I got that I just sent to your servers. So this is a perfect opportunity to talk about are we training all the bots with this free model that I just downloaded and sent to your server? So do you want to talk a little bit about that? I think it's
yeah.
really funny, but I'll give you an opportunity to talk about
Yeah. So the very short answer is a big no.
it.
Um, we first of all, our model is a physics-based model. So what's happening under the hood is there's no neural network or AI system under the hood that's now doing all kinds of statistics. We're on the opposite path. So the engine is a physics engine that has all the laws of thermodynamics for a particular polymer programmed into it, and then does all that calculation um, for a particular G code. So no, we don't train any models, any AI models with your data. We don't actually train any AI models with anybody's data. Um, yeah, what happens is when you click optimize or simulate, your G code is sent to us. That's the only piece of information that we get. We don't get any other information from your slicer or from your computer except that G code. We then run the simulation on that G code. We only use the G code to run the simulation, and then for the personal plans we delete within 30 days. So within 30 days, that G code is completely deleted off our system, and we'll never use it for anything else. No human being will see your G code. Yeah, uh, I hope that clarifies things.
Yeah, I think that's good for people to know kind of what your how your product works or whatever is not by training off of all of the models that we're sending there. I make the joke about, the free one here, but I could see somebody that's designed something with some intellectual property being leery of sending things somewhere that they don't know what's going on or what it's being used for. So it's good to kind of clear that up and let people know that your engine is physics based and not AI based, and the G code is, from what I got from what you said, is pretty useless to you. Even if you did have it, like what would you be using it for, right? So
Yeah,
and it's there, I think, for our benefit for 30 days and then deleted on our behalf for personal privacy after 30 days as well. So that's good to know. So thank you
yeah.
for clearing that up. All right, so back
And
to go ahead.
yeah, just on that basis, where we have so we also have a business plan, and the business plan is then 24-hour deletion. We
Mm,
provide additional concurrent simulations and optimization, so you can run multiple simulations in parallel, multiple optimizations in parallel, and we have a even stricter kind of service level agreement around privacy. But in both personal and in business, we take that privacy aspect very, very seriously. Um, we're part of the 3D printing community as well, right? We don't want to treat other people any differently from how we would want to be treated.
yeah, I really, really appreciate the clarity on that, and definitely wanted to give you an opportunity to kind of clear some of that stuff up for everybody. So let's talk a little bit about the optimization here. So this is a shorter print. It's not a, like a huge print, but even, a minute optimized there. And it's being a functional print, like a little mount for a camera, making sure that it's a little bit stronger and had some improvement on that, is good to know. And this again gets back to kind of that journey of where I've been with 3D printing, especially with functional prints, and then getting even to, simple things like this. And this is another thing that you could go to the store and buy, or you could 3D print it, and I think it's going to take 30 minutes or something like that to print, and even have it
Yeah.
optimized to be, quality as good as what you're going to get, or not better than the quality that you're going to get at the store.
Yeah, and there's something special about making things yourself, right? I mean,
Yeah,
it's
it feels good.
power, right? Yeah.
Yeah.
So here in this case, we didn't see a huge print time improvement. Maybe to give an example, like let's say a Benchy, right? With polycarbonate, every material is different, but with polycarbonate, a Benchy will go down for me from an hour and 10 minutes through down to like 50 minutes. So you get about a 20-minute improvement on a high quality Benchy. Um, in this particular case, because it's a very flat object, right? We with not much differences in layer time. We're so the layers are all roughly the same size. We're not seeing as much improvement. We're low to the ground. With polycarbonate, if we had an object that was more three-dimensional and kind of taller, then we'd start to see bigger benefits because we know with polycarbonate that we see cracking and problems as you get taller, right? So it's just a characteristic of polycarbonate. Under that, you've got average improvement and consistency improvement. So this window is completely new in the new version. What we've tried to do is
Mm-hmm.
kind of say, okay, you optimize, and now we give you a report card on how well your optimization ran. So print time improvement, okay, gives you how much time you saved. Average improvement is how much the average quality improved. So we're taking the average of all the little elements of the print. We say, okay, that one had a quality index of 20. That one had it went from 40 to 20. This one went from minus 40 to minus 20. So all converging towards the zero, which is where we want them to converge to. And then we'll take an average for the whole object. And that was medium in this case. And then the third one, what we do is we do a consistency improvement, which is effectively the standard deviation of all those thermal quality index values. So getting an idea, okay, in terms of the spread of everything, how much more homogeneous did we make the printing quality of this part, right? Um, so I hope that explains those three new
Yeah, definitely.
reports.
Yeah, definitely. I thought this was really cool because, you know, you optimized it, but what did it optimize exactly? Like, how do you quantify the optimization? So I think this is really good to see. And most of the stuff over the past couple of days have only done like 10 or 15 prints. I think most of them have been low on both, and this is the first one that's shown medium. I haven't done a Benchy, and we could actually do a Benchy, and see what that looks like really quick.
Oh, cool. You've got a different Benchy.
Yeah, on this channel we use the Nimitz Benchy. Is the Benchy of choice for this channel here. So we'll go to optimization, click yes, and start optimizing that one.
Where do you get the Nimitz Benchy from? I should get that too. That's
I
really cool.
think it's on Maker World, but I got it like 2 years ago when I first started my channel because I wanted to use a different test thing than everybody else. Everybody was just using the normal Benchy, and I think I found this on Thingiverse was the first place, but it's on Maker World now, and I think there's a couple of different versions. But it's cool because it's like has an aircraft carrier thing on it and
Yeah,
everything. It's really
that's
cool.
neat. That's neat.
Yeah, it's called the Nimitz Benchy. It has little airplanes on it, and it's the same principle. It has all the same features or whatever, but that's what I use on this channel for this one.
So if I'm at a maker fair and I see somebody printing a Nimitz Benchy, I know they're a fan of your channel.
They're most likely a Lynn Dizzle fan for sure. And the last print was I think a 24 to 23 minute print, and it optimized it fairly quickly. And this one still, just a couple minutes, and we're halfway there, almost three quarters now. It seems to be running a lot faster, and you support all the cloud compute cost and everything to do both the optimizations and the simulations, correct? Even the free simulations go to um, a cloud compute engine, right?
Yeah, yeah. So we do everything on AWS. Like we're running this. You're in North America, right? So
Mm-hmm.
all of it will go through a North America AWS server. And then yeah, it's different region to region. And yeah, we pay for all the cloud compute costs. So the free simulations, that's all costs that we just cover for the community.
That's really, really awesome. And thank you for doing that, especially on the simulations. Really
Yeah,
appreciate that from the entire community. Thank you for doing that.
no worries. We like this has been such a long journey, right? For me, Helio has been a 5 year journey so far. And technically, what's happening here is just to see it working like this in the real world with you, it's like a dream come true, right? It just gives me so much pleasure to see that we're finally, after so many years, at this stage where anybody, you, me, my 12-year-old son, we can benefit from this technology. It's just a wonderful feeling.
Yeah, this is really cool. So on this one, from an hour and 45 minutes to an hour and 24, so 21-minute improvement in time on the Benchy is pretty significant. For less than a 2 hour print, more than 20 minutes
Yeah,
saved is pretty substantial.
and you can see average improvement was medium again, so that's good. Consistency improvement was low, which means it was already pretty good before. And so effectively, what that means is there were outlier areas that were not that great, and it fixed those. But if you look at it, the standard deviation overall, it was already pretty good. Yeah, and it just fixed certain areas. That's how I would interpret that. Um, Then we have a couple more factors, a couple more new features here. One are these stars at the bottom. Can you see those stars on the
Mm-hmm.
bottom left?
Mm-hmm.
So what we're doing here is users can give feedback on how they valued this. So this is not a print feedback. I mean, obviously you haven't printed it yet, so you don't know, but this is at least a feedback. Did this match what you were, did you feel that this was a result that you were disappointed with or you were pleased with? So I like that you gave it a 5 star. And then you have the option next to the OK button, there's a little save button, right? And this gives you the option to save your G code to a folder somewhere. And the reason we added this in is because, um, whenever in Bambu Studio, if you go back to prepare and do something, then your G code is gone and you have to reslice, right? So
Mm-hmm.
we wanted to give people at this point the opportunity to archive this particular optimized G code so that you could revisit it later, even if you made some, setting changes and had gone back to the slice before slice in Bambu Studio. So those were the other two changes that people had requested that we put in here in the report card.
Oh, that's really cool because I was just using the you can save the G code to a file
Yeah,
on the print thing as well. So that's really cool tip to know that it's right here and you can save that if you need to print it again. So I thought that was really cool because like once you've optimized something and you want to print it again, you don't want to have to do the optimization all over again or whatever since you've already done
exactly.
it. You just want to use it again. So that's really cool that you have the save right there. That's awesome.
So this is also an example. We're getting tons of feedback back from these first 30 days of users, or I think we're at like 37 days of users now. And that feedback is already going into new feature additions and usability changes. So I hope I hope we can get way more feedback from your community as well, and then we can integrate that feedback and make what we're doing even more powerful.
Yeah, definitely. If you'd like to sponsor my live stream with some free optimizations, I could definitely get you some users.
We can definitely do something like that. Yeah, that would be awesome.
Then everybody tune into the future live streams and look forward to possible free optimizations with that. Or maybe we can have a contest on who can get the highest score on optimization and send in a print of that. I think that would be awesome too.
Yeah,
So if you can beat my medium low, send me a picture of your optimization higher than this, and maybe we'll run a little contest on that as well. I think that would be awesome to see kind of some of the results people are getting as well. I think that would be kind of cool to see.
yeah. And we can sponsor some free optimizations to your winner.
Awesome. Awesome. We'll put something together. So everybody out there join the live streams and we'll put something together and do some contests around that. So really, really cool. I learned a ton today. I kind of did my homework and I thought I had understood everything here, but I did not even realize there was a save button here. The scoring thing here was new to me. So I learned a ton today and I hope everybody else did as well. I think there's do you want to do the Dolby Intel Inside analogy?
I can do that. I mean, people ask me, what is, what are you at Helio Additive? And the other day, I was chatting with somebody and said, you know what you guys are? You're like the Dolby Inside, a quality mark that powers what's how the experience for the user. And I was like, wow, that's a really good analogy. And so I've started using that more and more. And for me, the effect of the kind of the result is exactly that. We're an engine that helps power quality, speed, and performance in 3D printing and desktop 3D printing around the world. We're integrated into what you're doing already in 3D printing. So just like, Dolby makes your sound amazing in the theater, well, we make your prints amazing in the home.
I really like that analogy. And it makes sense. I think it gets back to your race car thing as well. Like, if you have this wonderful like surround sound and all of that, why are you gonna put mono audio through it, right? You
Exactly.
want surround sound, you want that Dolby or Dolby Atmos or the different things to kind of match the things that you've done. And I think with Bambu, that's kind of an easy thing too, because the whole reason that you and I think most of my users will agree here, the whole reason that we have Bambu is because it's high quality and easy to use. So why not put the Dolby inside of your Bambu as well. So I really like that analogy. I've spent a lot of, time, effort, money on all of this stuff. So why not give it the best that can have, and, really optimize everything. So I really like that analogy.
Right.
Is there anything else that you wanted to share with the audience, now that we have you on here, now that you have this audience in front of you? Is there anything else that you'd like to tell us or to highlight today?
I think we've covered really most of the parts of Helio Additive, and getting to show a live example is, I think, really cool. I think mainly to all of your community, just want to say thank you very much for supporting us, and we're looking to give you this power in 3D printing. Please interact, give us feedback, reach out to us. Yeah, and we're really glad to be together on this journey.
Yeah, thank you. Thank you for the partnership in the video. Thank you for joining us and kind of walking us through the software. Really, really cool. Really enjoy your company, and I think you're a great person, and I can't wait to do more with you in the future. So as you add more stuff on, come back and join us and show us all of the cool stuff. We'd be happy to have you on here as you continue in your print journey. And with that,
Thank you so much.
if you liked today's video, be sure to smash the like button. Be sure to hit the subscribe button so you don't miss the next one. And don't miss our live stream so you can try out the Helio Additive optimizations for free and show off some of your optimizations. With that, thanks everybody. Thanks for watching.